what's missing from this pack that we have is the rate in, rate out, and that's going to be at least you will see this in the FRQs. So we'll see this the first time today, and after we're done with integrals, we're going to do it one more time because there's going to be another set where we need to use the integral. The integral sign is this, you'll learn later. Okay, we're going to take notes on this page and the next page. We'll take a small mental health break of 2 minutes after this page, and then afterwards, the rest of the time will be yours to study. Okay. Oh shoot! I forgot to upload the answer key. I'll do it a little bit later. Okay. All right. Let's get started. You'll see what I mean by rate in, rate out problems. The birth rate and the death rate of a certain rare spider species are given below as tabular data. Tabular data is just table data, where both functions are twice differentiable. They always have to make sure it's differentiable, because if a function is differentiable, what can you conclude? It's continuous, and that's the only time we can use all of these theorems. Okay, both B of t birth rate and D of t death rate are measured in spiders per month, where t is units. Okay, maybe they're in the lab. I don't know where they're at. So, but here's the data. Okay, calculate B prime of 2. Interpret your answer in the context of this problem using appropriate units. Well, hopefully by now you know how to calculate B prime of 2. We don't have equations, but we only have tables. We don't see a time of 2 months over here. So, and I'm just going to block off the death rate because we need to see just the B. You tell me what to write over here. B prime of 2 is approximately what?
B of 3 minus B of 1.
Yeah.
3 minus 1.
And I'm hoping after all of this, you at least get that point. So like I said on the AP, you write this down. This is 1 point already. Okay. Let's just do the mathematics. B of 3, I believe. And just be careful, especially when their tables are like this. Make sure you're reading this. Okay, so it's 50 minus 45 and not 60 minus 70. Okay, so just be careful with it. Whereas are at 50 minus 45 divided by 2. This should be some light calculations. 5 divided by 2. Now we can go 2.5 over 1. I don't know. That should be okay. Okay, our derivative is positive. Okay, we always have to go back to what is increasing and decreasing. So your B, what is your B measured? Your birth rate. So start off with that first. So what is increasing? The birth excuse me, the birth rate. Okay, so your function, your noun, so the birth rate of spiders, or the spider's birth rate, whatever English equivalent you guys want to use, is increasing. Let's take a look at our units before we write down the units. What are your units for your B of t? What is that? Spiders per month. So I'll just put that over here. So this is spiders per month. And then the 3 minus 1, like what is that? What are those units over here? What are the units in the bottom denominator? Months. Good. Okay, so spiders per month divided by month is going to be 2.5 spiders per what? Month squared, yeah. Squared month, month squared, yes. So we write down months squared, but then we say squared months. Okay. Spiders per squared months at t equals 2 months. Okay, and that should be good. Your noun, what is it doing? Increasing, decreasing? Number, unit, and time. Okay, now the new ones, and I'll also let you know, like, after we do number 2, 3, and 4, I feel like we're not even doing calculus, but when we get back to the integrals, we'll do this one more time, and you'll see why we have to use the calculus. Is the spider population increasing or decreasing at t equals 3 months? Give a reason for your answer. This is why it's called rate in, rate out problems, because this is going to be your setup when they're asking you if the spider population is increasing or decreasing. You need to consider the rate coming in and the rate going out. in this case, the birth rate minus the death rate. So your setup is rate in minus rate out, or in this specific problem, B of 3 minus D of 3. Remember, B and D are already rates already. They're already spiders per month. So you do not have to take the derivative of these. They are already the derivatives. Okay, well, good thing we're given tabular data. It's what minus what? Yeah, 50 minus 60, and should give us a nice number, negative 10. Okay, so this is what you're going to write. Because our derivative value is negative 10, we're going to say that the population is decreasing because it's negative. But this is how I want you guys to write it. The spider population is decreasing. Okay, because we had a negative value, I know you guys are still writing, I'll just say it a little bit slow. The spider population is decreasing at t equals 3 months. Why is that? Because when we did the calculation, B of 3 minus D of 3 is negative. So you can say is negative, that's fine, or less than 0. They're the same thing. Okay. On top of that, the death rate, the D of 3, is greater than the birth rate at t equals 3 months, and hence that's why it is decreasing, because that value subtraction is negative. Okay, any questions on those two sentences? In those two sentences only, you should not be making a speech out of this, like an intro, body, and conclusion in whatever class that speech class is. This is it, those two sentences. Okay. Any questions on that? So, with that said, number 3 should be a little bit similar. Is the spider population increasing and decreasing at t equals 10 months? Tell me what's right over here on your math calculations. Go. Before that. Yes. Okay, in the middle of that. Yes, yeah, there we go, Okay, yeah, okay, there we go. It's all right. B of 10 minus D of 10. So that's your setup. Okay, now we can put 75 minus 45. Okay, 30? Yeah, it should be 30. Okay. All right. And then it should be the same structure of the two sentences that you see above. You tell me what's right. I will start with the spider population is increasing. Thank you. At t is equal to 10 months. Yep, thank you. Thank you. So this time around, the birth rate I know it's a lot of writing for math, but those two sentences will give you your justification. You can also be flexible with the second sentence. If you have any other English equivalent, the birth rate is greater than the death rate, you can say the death rate is less than the birth rate. You know, anything that is equivalent to that, that is totally fine. Okay. Any questions on numbers 2 and 3? Any questions? Okay, after we do number 4, let's go take a mental health break. Okay, now in number 4, in between these intervals, 1 and 10, is there a time t where the birth rate is the same as the death rate? Explain why or why not. So what they're wanting us to do is we need to show that b of t minus d of t, if they were the same rate, if we subtract them and they're the same rate, what number should we have over there if they're the same rate? 0, yes. So we're trying to prove, is there a time where they're going to be the same? If we subtract them, then it's going to be a 0 spiders per month. Let's kind of take a look. I mean, we can kind of go back to our tabular data. I think we already did 45 minus, did we do this one? 45 minus 70. I mean, on top of your head, is that going to be positive or negative? So this is going to be negative. How about 50 minus 60? Positive or negative? Negative. How about 56 minus 54? So now it's going to turn positive, and then all of this is going to be positive over here. Okay, so there is some sort of time in between, and more specifically, probably somewhere over here, that the birth rate and the death rate is going to be the same. Now, they're not asking you, of course, the time, but we probably can use something in the middle. Hint. What theorem is that in the middle? Intermediate value theorem. Okay? Step 1. One more time, you need to state continuity. In order to use the theorem, we got to state that first. Well, what do we know about b and d? What kind of functions are they? I think it's on the first sentence, where both functions are twice differentiable. It just means you can take the derivative twice. So, since both functions are differentiable, and you can just set this one up already. B of t minus d of t, whether you add them, whether you subtract them, is continuous. Step 1, state continuity. Once you state your continuity, then we have to evaluate the endpoints. Even though we can kind of see, and you can probably use 3 and 5, let's just follow with 1 and 10, because those are your endpoints over here. So what I mean by this is we're going to do b1 minus d1, and then afterwards we will do b of 10 minus d of 10. Okay, well that is 45 minus 70, and negative 25. I'm running out of room. Okay, so it's a good thing we already did b of 10 minus d of 10 on the previous problem, so that should come out to 30. Okay. So hopefully you guys can see that, okay, when we did the first time around, it's negative, and then now it's a positive. So, and because it's a continuous function with no holes or no vertical asymptotes, it's got to pass the x-axis sometime. It's got to pass where y is equal to 0. So now we can do our conclusion. So, 3, conclusion. Since take your lower value first, b of 1 minus d of 1 is less than 0, is less than b of 10 minus d of 10, your highest value. I usually put C over here. I'll let you guys know it really just does not matter. If you just want to keep using T, that's actually, that might even be better sometimes. There exists a time T, it exists somewhere. in between 1 and 10. So again, we're not including 1 and 10 because intermediate value theorem, you want it in between. So there's no equal to sign here. Such that B of t minus D of t, such that the death rate, the birth rate is the same as the death rate, or when they're equal to 0.